that. All right, so moving on. The first session is on access active archive use cases. And so the first speaker, who will be Tim Sherbach from Enterprise Products and Solutions at Quantum. And he will talk about the intersection of cloud repatriation and active archiving. Over to you, Tim.
Great. Thanks, Drew. Next slide, please. So in planning the seminar, we talked a lot about cloud repatriation, and specifically a trend that's happening now is that organizations are reevaluating kind of this cloud first mentality that they've had for some amount of time, given just the data growth that we've experienced, the just large adoption of cloud over a long period of time now. There is now an increasing focus on lowering costs and improving their cost predictability, as well as improving data accessibility, and for many organizations, a concern over control of their data, security of their data, sovereignty of their data. And so one of the first things organizations need to think about when they're considering repatriating some element of their computing environment is what to repatriate, right? Workloads, data, workloads plus hot data. And of course, here in this crowd, in this audience, an active discussion about active and cold archives and how can you leverage your own infrastructure in order to build active and cold archives. So next slide. So the most important thing I think to take away is that when you're evaluating repatriation, it doesn't really mean turning back the clock to the infrastructure that you had prior to the cloud adoption. It really means building your own private cloud and thinking like a hyperscaler, recognizing those values and those aspects of a cloud-based storage solution that you specifically like and value. And so the scenario here is that you really want to evaluate and start to architect and evaluate potential solutions in this environment in terms of the simple access that REST interfaces provide, efficiency by virtue of a multi-tiered, low overhead infrastructure that can be very efficient at storing your data. It has to be durable and available, and that means vehicles for protecting the data, as well as protecting against site failures with some multi-geo solution, as well as making sure that your data is secure. And then, of course, one of the great values that cloud storage has is this attribute of scale out capability and the ability to have both performance and simplicity at scale. And one of the things is you don't have to do it all yourself, right? Because there's many solutions today, many resellers, many managed service providers beyond the classic hyperscalers that can build as a service solutions or managed service solutions for you that allow you to build your own active cloud storage infrastructure. And one of the other things you got to think about is think in terms of the long term and making sure that it's adaptable, easy to evolve, and adopt new technologies over time. So the whole concept here is really that you can achieve lower costs through no transaction fees, lower storage fees, no egress fees by building your own infrastructure. You get better benefit of the hardware costs that happen over time than you would in the cloud. And ultimately, you own the cloud, and you can build a cloud that is comparable or even less than the cost of a public cloud. And one of the key elements to support that is thinking in terms of cold storage. So with that, next slide, Drew. Okay, so here are here's a little bit more in terms. This is echoing some of the thoughts that John had as well. Is that the key to savings is really building an effective solution across multiple storage media types. If you look in terms of tape, disk drives, and solid state disks, you can see that there's a dramatic cost difference between each of these elements. And so it's going to be very important for you to map in, catalog your data, and then map it in such that you can place it into your infrastructure simply and easily. And there's many solutions, both in terms of analysis and cataloging software, as well as seamless environments built through these multiple technologies, such that you can migrate data seamlessly between these ultimate technology types. And so when you're thinking about building this private storage cloud, you want to think like a hyperscaler in building it using these multiple classes of storage, and then making sure you have the data management infrastructure that allows you to migrate and move data meaningfully across these data types. So with that, I'm going to hand it back to Drew. Thank you very much for attending today.
Thanks, Tim. And next, we're going to hear from Bhupinder Bueller, the CEO of SwissVault, who's going to be talking about edge computing and active archive data storage use cases.
Thank you very much, Drew, and hello, everyone. So we are SwissVault, and we are developing software and hardware solutions to enable, as Drew mentioned, resilient data storage and using low-power computing at the edge. So I will present some examples of our work on edge computing. And edge computing, if you are not familiar, brings computation closer to the data source. We're reducing latency and bandwidth requirements and enabling faster critical decision-making. So our aim is to enable increased data processing efficiency, responding to all the signals that we're monitoring, and making the whole operation for the use cases I'm going to discuss in a second, making the operation very cost effective. So as an example, I'll give in agriculture and healthcare, but many of you may know about exciting applications for autonomous vehicles in smart cities, for example. So on this slide, our edge system, which we call our edge ecosystem, is composed of 3 systems. In the environments we are working in, we're collecting lots of data from lots of sensors. They include monitoring humidity, temperature, air quality. We're also collecting data from IoT devices like cameras and RFID sensors. In the healthcare example, we're collecting data from many wearable devices like smart wound bandages. So in our design, we have to know what is the data collection stream from these sensors. What's the frequency of data collection, and what's the processing and storage requirements for our clients and so. So the edge node that you see in the middle is our own design, and this processes the incoming data. The edge node does the data filtering and the pre-processing, such as noise reduction or data cleaning. It has low-power GPUs to support AI applications. So remember, implementing AI algorithms are at the edge enable us to do very quickly object recognition, anomaly detection, or even predictive maintenance on systems at this level. And so it's not to do large machine learning at the point because there's not that much computational power at that edge. The edge nodes run real-time analytics. The one in the center runs real-time analytics to drive immediate insights as well because of this capability. But more critically, almost all the clients that we're working with right now want to store data on premises. Many of the clients are European-based, and so the GDPRs are actually regulating this. So the data storage has to be optimized. That's at the edge here, in the edge data storage. It has to be optimized for access and long-term retention. And the reason is because in these early stages, a lot of research data has been generated. And this is for future optimizations. You need to be able to run a lot of analytics on this data. So what we do is at the edge is we distribute the data across a number of the edge data storage nodes. This is a geo distribution algorithm that we have for data fragmentation and storage. The data is stored on disks for easier accessibility for these analysis I mentioned. The data is processed at the edge, may sometimes need to be transmitted to central servers on cloud for further analysis because some applications run on the cloud. And last but not least, but the data has to be encrypted and secure at rest and in transit for some of these sensitive applications that we're talking about. So next slide, please. So here's an example of an edge network in agriculture. So I believe, and many of the people that we're working with believe that edge networks will revolutionize agriculture by providing real-time monitoring and analysis of conditions like soil conditions, weather patterns, and crop health. And these systems allow farmers to access data-driven insights in these remote areas. And of course, one of the things that we talk about this access part is that it's also bridging the digital divide and fostering sustainable agricultural practices. So in this process, what you see is a lot of sensors here monitoring humidity, temperature, and soil conditions, but we also have a lot of equipment that we have to manage. So these includes cameras, humidity or light panels, and all that is collected on the edge node that's shown here, this SV edge node. And the clients are also accessing the data on the edge node to run the real-time analytics. So this is done in a project that's already live in Austria, and where we have a vertical greenhouse that's being operated for medicinal plants, etc. Next slide, please. So in healthcare, edge data will also revolutionize healthcare by bringing data processing decision-making closer to the point of care. And what we have is a number of different examples as shown at the bottom there, but we're working on a smart wound band-aid. The client with a smart wound band-aid, this is detecting a number of biomarkers and conditions at the wound site so that you don't have to remove these bandages. They can leave them out. The patient doesn't even have to come in. They can be remotely monitored to see the availability of the healthcare, the progression of the wound healing. But suffice to say, there are a number of monitors that are being done right now, monitoring for healthcare that are such as wearables that are being done, which we're trying to integrate into be able to collect using our edge node the information from these patients. So with these two examples, I hope that you got a good example of how we're using edge to enable access for data for patients and also agriculture. Thank you very much.
Thanks, Bhupinder. So next we have Jason Thuneson, Director of Clinical Solutions at Mediquant, who's going to talk about how can healthcare entities ensure seamless access to legacy data without compromising on efficiency or security.
All right, thanks, Drew. So while this section does focus a bit on the healthcare space, certainly the lessons here can apply industry-wide, right? So a growing amount of technological inventory is simply the cost of doing business. But if we look at just the data landscape that is particular to the healthcare space, some of the challenges we have in healthcare right now. We have larger hospital systems that have aggressive acquisition strategies. Each application or each health system that they are acquiring or each provider office that they are acquiring comes with its own set of solutions, comes with its own set of data challenges, and it comes with its own data management strategy. So it's a matter of blending those policies, but also taking a step back and viewing that macro level or viewing the enterprise-wide level. You have applications that manage your clinical workflow, each with its own regulations for how long you have to hold on to this data. For your enterprises that expand across state lines, each different state can have their own regulations and retention policies. There's financial applications to manage the revenue cycle for each of these facilities across the enterprise. Other applications like HR payroll, accounts payable, general ledger. And all along the way, if you do not have an effective way to manage your legacy or your current application inventory, it's very easy for redundancies to happen, financial inefficiencies to happen. It's also very easy to fall out of compliance with your organizational policies and procedures, as well as government regulations. So if you think of, particular to the healthcare space, we have the 21st Century ONC Cures Act, with its own amount of penalties that are actively being rolled out now, dedicated to things like information blocking, not being able to produce clinical or financial data when needed. So there's lots of challenges here and lots of applications that can fall under the radar with data not being effectively managed. So with the next slide, we'll discuss the importance of our active archives. First, it's a matter of extracting as much value as you can with the data that you're already holding on to. Keep in mind, anytime you're archiving anything, it's not just the healthcare perspective, but again, industry-wide, keeping that data alive and accessible and considering all of the use cases that you have. In the healthcare space, it's very important for something like continuity of care. It prevents duplicative testing on patients. For example, there's value, there's research in the healthcare data that's being held as well. When we're looking towards the financial space, you have legacy applications where you're managing a large amount of accounts receivables and outstanding bills and outstanding financial recovery or accounts receivable balances from the patients that have been treated. There are active archives that effectively allow you to or enable you to decommission those legacy applications, stop paying all your licensing and support fees, and work down those accounts receivable balances from within that archive space. So making that data live, accessible, and usable by your enterprise, even after that application has gone full legacy or decommissioned. And that's all going to lead to the compilation of that seamless and cost-effective storage, realizing your redundancies and picking up one seamless strategy for the management of it. And then lastly, it's on the next slide here, it's about visualizing that legacy data, learning lessons from the past, and using that to drive your future insights. So even though that data is legacy, let's say, it's 2, 3, 4, 5 years old, there are still lessons to be learned there. Particular to the healthcare space, research is how we get better at treating our patients. It's how we form evidence-based practice. So you could look in the past and say something like, okay, that urgent care clinic that we built 10 years ago has effectively, if you look at the past 10 years, decreased our emergency department admissions by 40, 50% for this region. So even though that data may be maybe a few years old by now, it can still be used to better your organization, to learn lessons and discover efficiencies in the future. So all of those will culminate into an effective legacy data management program through an active archive. All right, back to you, Drew.
Thank you, Jason. Next, we're going to hear from Rich Gadomski, the tapes technology evangelist at Fujifilm. He's going to talk about an active archive for video surveillance content.
Thank you very much, Drew. I kind of view this as an emerging active archive use case. And what's happening today is that there's an incredible growth in the amount of video surveillance content that's being produced. But if you think about it, there's a proliferation of really inexpensive, call it cheap, high-resolution video surveillance cameras, in almost every single aspect of life today, whether it's hospitals, universities, office buildings, shopping malls, city streets, theme parks, sports venues. I mean, it goes on and on. And we really, and it's a great thing for security and for safety of people and property. But it is generating a tremendous amount of data. Take, for example, an installation of 500 1080p cameras, 30 frames per second, 90 days worth of retention. Over 5 years, that's going to generate 4.2 petabytes of storage, not an insignificant amount of storage. And when we look at IDC data, the entire video surveillance industry consumes 100 exabytes of HDD per year. That is a tremendous amount of data. In fact, 100 exabytes is equal to 5.5 million HDDs or 5.5 million 18 terabyte LTO9 tape cartridges. So think of the costs and the energy associated with video surveillance, and it's only increasing. The resolutions of cameras are increasing. Retention periods, people want to keep content for longer periods of time. Folks are applying artificial intelligence analytics to video surveillance content. So now you want to keep that content for longer periods of time. So it all adds up to quite a storage challenge. So on the next slide, we'll see that active archive is starting to play a role in this market. And this is a schematic that's courtesy of a company called Cosent. But Several of the Active Archive Alliance members are also supporting video surveillance today, including QStar, Zendata, StoreMagic, Quantum. So basically how it works is, video content is being stored on HDD on servers for, say, for a user-defined period of time, say 14 days. But it's also being stored in the lower right-hand corner in what is called here a vault storage or a tape library system, LTO tape library. So after 14 days of content being available in hard disk, when the video surveillance operator is searching back beyond 14 days, then it starts to tap into the tape library, or what we call the active archive. Very, very low latency. You're talking about 3 to 8 minutes by the time it transitions from disk to tape. So that's user friendly. Traditionally, archive is kind of a four-letter word in this industry because video surveillance operators didn't want to wait around, an hour or two or more to get video content from an archive, nor did they want to have to deal with an IT department or some sort of manual labor intervention. So it is truly an active archive in the sense that while the content is moving to a much lower cost tier of storage, much lower energy consumption, it is still online and available all the time to the video operator. And again, very low latency. So really this is a two-tier system where a tape library system can support an HDD, instant access. So two-tier tape supporting HDD. And this enables longer retention periods at original resolution of the content, which is important when you do need video content for, say, evidentiary reasons. Okay, next slide. We'll see that the TCO benefit is pretty substantial. So in the example that we were talking about at 500 cameras, 1080p, using a mix of both tape and disk would yield a 58% cost reduction as opposed to keeping all that content just on disk. So you're talking about $430,000 in the right bar compared to $179,000 if you implement an active archive supported by a lower cost tier of storage, such as LTO tape. And energy savings, definitely plays a part in the cost savings. Tape consumes 87% less energy, produces 97% less CO2e. So when it comes to video surveillance, archive, no. Active archive, yes. So I look forward to working with members in the industry on really promoting this concept. Thanks very much, Drew.
All right, thank you, Rich. And next, we're going to hear from Bruce Kornfeld, Chief Marketing and Product Officer at StoreMagic. And his topic is, what challenges do retailers face when running applications and storing data in the stores? All right, Bruce, over to you.
Great, thanks very much. Thanks for having us here. So, yeah, you can just go to the first slide here. So I would just say this. First of all,
I still can't hear you.
Looks like he's adjusting his speaker now.
I've been on these things all day, and apparently they decided to die. So can you hear me okay?
You're back with us.
Good timing. Sorry about that. Okay, so let's talk about retail. So a couple thoughts here. One is, no matter what the industry, the beginnings of any good archive starts with the data that's being created. And that's the theme that we're going to talk about here, particular to the retail industry. So there's a lot of innovation going on in retail, as we probably all know, because we're all consumers in one type or another. And just think about what's happened just in the last few years with technology advancements. COVID was an accelerator for this for some retailers, but these days, did you ever think of the day where your mom and pop local Vietnamese restaurant, you can go online, place an order, and you can just show up, never talk to a human being, just pick up your bag and leave? Like, the technology changes, and that's a small example. The big folks, the big box retailers, they're doing so much to optimize how they sell, what they sell, optimize every bit of revenue and profit, that there's a lot of innovation going on. And what that means is, the term edge computing was used earlier, there's a lot going on at these edge sites. A lot of these retailers have made the decision that they cannot depend on cloud for everything they do in the stores. Cloud is just, in many cases, too slow, not reliable, and frankly, just very expensive. So we're seeing a lot of retailers that are having to run their applications on-site locally in what was referred to as edge computing. And that's pretty much the world that StoreMagic lives in. We're all about simplifying storage for our edge computing customers. But in retail, they're dealing with a lot of these challenges. Now that they're trying to run everything locally, they've got lots of devices and sites to deal with. Downtime is a huge issue. What do? You can't have a store down for minutes, let alone hours or days. So downtime is a huge one. Budgets are an extremely big one, because most of these retailers are either small and every few $1,000s matters to them, or they're really big and you have thousands of sites and a couple $1,000s less at every site adds up really fast. They don't have on-site IT staff to do anything. It has to be able to be installed and managed, installed by a non-technical person, plug the power in, plug the Ethernet cord in and leave. Everything else is remote. Security issues are huge at the edge at these retailers, because there isn't physical security. There aren't badge access data centers. These servers are sitting under desks, under the point of sale, checkout counters, etc. So there's a lot of security issues that they're dealing with as well. If you can flip to the next slide, which is my last one, so hang in there. So what do these stores do? What are they looking to do? And what they do is they try to build super highly available edge computing solutions. So what we see is they take 2 servers, sometimes 3 or 4, but the minimum is 2. And of course, to save money, they try to get down to 2 whenever they can. You build a highly redundant HA infrastructure using software. Of course, StoreMagic software is in there, but we're not here to talk about StoreMagic. But they build these highly available solutions. And what they do is they run everything in the store on one cluster. So all of the data that's being generated, whether it's their digital signage, video surveillance was already mentioned here earlier or just before me, the point of sale terminals, analytics isn't even listed here, but that is something we're hearing more and more about. Retailers can't wait anymore to send data from all of their stores to a cloud somewhere, let the analytics run there, and then give the answers the next day to the store. They're wanting to run analytics real time in the stores. All of this is driving significant need for more storage, more data, and more HA, because these systems just can't go down anymore. So this is what it's all about. This is the area that StoreMagic plays in, is helping the retailers build these super highly available solutions so that the data can be created, captured, stored reliably, and then all of our friends around the table as part of the Active Archive, then we partner with them to then help our customers think through what data needs to be archived for a day, for a week, for a month, for a year, forever. And then we integrate into the Active Archive solutions from here on out. That's what I got, and I'm ready to turn it over to the next speaker. Thanks very much.
All right. Thank you, Bruce. We have a question that's come in actually for John Monroe. So John, are you there?
Yes, I am.
All right, John. So here's the question. Someone asking this for you. It's interesting that you see hard disk drives still being sold in volume 5 or 10 years out. Does this mean you think capacity flash will never overtake capacity disk on price per terabyte, or do you see disk maintaining other advantages, and if so, what?
Well, I think flash is going to be challenged even to get to a penny a gigabyte, which is where we are now with hard drives. Actually, we've been there for more than a year. And hard drives will probably get down to like 0.6 cents a gig. It'll come nowhere near that tenth of a penny, which are the goals of the other kinds of active archive technologies, photonic and tape. No, I don't believe solid state drives, even if they were the best thing available, even if they did get to a tenth of a penny a gig, how many can the fabs produce? How much can they allocate only to enterprise SSDs as opposed to industrial grade stuff, as opposed to all the PC and consumer stuff and the cell phone stuff they have to allocate? So I think the maximum production capability of the NAND fabs probably is only about 3 zettabytes out there, even in 2035. 3 zettabytes is woefully inadequate to service the ongoing needs of the enterprise. So no, I don't think they cross over. No, I think there's going to be increasingly more flash as a proportion of the total, but the proportion of the total that's going to be increasing at the greatest rate will be the active archive technologies that demand a whole lot less cost per gigabyte and a whole lot less power consumption. So another dirty secret about flash, guess what? They actually consume more power than hard drives. PCMCI interfaces are a lot more power hungry than SATA interfaces on hard drives. So there are a lot of things just standing in the way of flash being able to manage much more than a couple of zettabytes of this dataverse as it's evolving over the next 10 years. Now, hard drives, even though I do have them for the first time shrinking after 2030, they're still in 2035 probably about 1.7 zettabytes, which is larger than they were by a considerable factor last year. So no, they don't die. I think, and again, this is a both and scenario. This is not either or. Well, flash, I mean, I remember a lot of the meetings I had at Gartner, particularly in Korea, with the giants there. So, Monroe-san, what do we need to do to overtake hard drives, to take out hard drives entirely from the enterprise storage tier? I said, you're asking the wrong question. What you should be asking is, how can I most profitably address these evolving zettabytes in the total market? Not what I can kill, but how I can make money addressing things and providing solutions for clients.
Very good. All right, John, while we've got you, we've got another question coming for you. And
Okay.
we'll just short answer on this one so we can move on to session 2. So
Okay.
what will be the impact of AI on data storage and data
Oh, boy.
accessibility?
I'm working on a white paper with precisely that now. And I think it's going to be classically something where you have great accelerators and great inhibitors. And one of the key uses of AI, and I think it's pointed out in Rich's presentation, is determining what to store and where to store it, how to access it best. Certainly, it will act as a gatekeeper to say that, okay, a lot of this stuff that is being generated by the billions and billions of sensors out there, it'll be some sort of flash gatekeeper enabled by AI that says, no, we don't need to store this at all. We've already got that data. It's redundant. We don't need this. On the other hand, I think AI, as we all know, is happier, theoretically anyway, the more data you throw at it. The more data you submit to analysis, the better the analysis is. So I've got lots of thoughts about that, and I am working on a white paper with precisely that theme that will probably out hopefully by the end of January.
All right, thanks, John. Well, that concludes session 1. We're